so the official topic here, right, is the distinction between science and science fiction. That's the general topic. And Yakup has assigned an essay from the 1920s by the evolutionary biologist Julian Huxley called Tissue Culture King. I'm not going to actually talk much about that, but I will make a kind of remark in terms of how this fits into your syllabus, because I was looking at that before coming on today, and one of the things that's striking, I would say, and maybe Yakup could take this up in the future, is that it pretty much, the science fictional aspect of it ends with the early 20th century, it looks like, right, which is the time when Julian Huxley is writing. Of course, science fiction has changed considerably, and in fact has become much more important over the course of the 20th century, right? So the 20th century actually is the century when science fiction becomes such a big deal, and in a way seriously influences scientific thinking, okay? And a lot of that had to do with various kinds of changes that were taking place in science in the 20th century that really kind of opened people's minds in a way about what the future might be, in a way in which perhaps science previously did not. Okay. And so I want to, in a way, I want to kind of specify that as kind of an issue, because, and this will anticipate things that I'm going to be saying later in the talk. Of course, there are these, there's evolutionary theory, Darwin's evolutionary theory. But Darwin's evolutionary theory, as it originally was conceived by Darwin, was in a sense a kind of theory of natural history, right? That is to say, and this is what, evolution means when it gets right down to it, right? That there's a sense in which there is a kind of way in which organisms have changed over the course of not merely thousands of years, but millions of years, and now we contemplate billions of years, and this is something that in a way is very much part of the way in which the Earth in general is changing, right? So you're familiar with natural selection. But what Darwin really could not explain, so what Darwin's Origin of Species was very good at showing was in fact that there's been these, what seemed to look like lines of descent, right? Lines of descent between different kinds of organisms, and the fossil record, which was in a way just beginning to get seriously looked at in Darwin's day, continued to vindicate, right? So that the lower you go into the Earth's surface, right, the more primitive organisms you find, but you can, in a sense, see that different layers provide the basis for different forms of life that in some sense are similar to, but in a way different from the previous ones. And so this is kind of the framework in which Darwin's theory of evolution by natural selection was developed. And it was very compelling to the people in mid-19th century Britain, largely because it was very comprehensive, right? So in other words, Darwin was able to give a kind of big picture, but at the same time was also able to zero in on particular species differences that, in a sense, also vindicated the general theory, right? And so you may know about, Darwin in his early life, before he wrote The Origin of Species, sailed around the Earth, right? And so there are these Galapagos finches, right, which you've probably heard of, right, which in a way sort of establish the way in which speciation happens. And speciation is how species differentiate themselves from each other. And according to Darwin, it's largely because of differences in environmental pressures, right, which determines whether a species lives or dies. Okay, that's a basic picture. And it was very compelling to people in the mid-19th century, largely because it seemed to be a self-organizing theory. In other words, you don't have to talk about God, right? In a sense, you can just start from what Darwin himself called the primordial soup, right? So in other words, you start with this kind of non-life, basically, of complex molecules that through some kind of transformation, and this could be a physical transformation, like a change in the climate and so forth, in a way brings them to life. Right. So, in other words, it's not done by design. And in fact, part of the reason why it's quite normal to associate evolution with a very long time period, right, is because this stuff happens in a very probabilistic, statistical. People talk about random. Is not quite the right word, but nevertheless, it isn't a straightforward story of progress. For example, right? Evolution in a way, you have certain kinds of organisms that are stabilized for a certain period of time, and then a change to the environment happens by whatever means, and then you get another bunch of organisms, right, that are able to survive in the new environment, right? They're made fundamentally of the same stuff, but they are different in terms of a lot of important characteristics that enables their survival. Okay, so I'm saying all this about Darwin. Fine. Um, but I think the thing that you need to keep in mind is that what Darwin couldn't do is to explain how it happened from the standpoint of the mechanics of the organisms themselves. In other words, Darwin did not have what we would now call a theory of genetics. Okay? So Darwin gives you the big picture. He kind of gives you the picture from the outside, as it were, without actually knowing what's happening inside. Okay? And when I say inside, I mean inside the bodies. How does reproduction exactly happen? Right? What is reproduced exactly? Right? That enables species, in a sense, to sort of, in an imperfect way, copy each other, over time, blah, blah, blah. Right? That's the sort of thing that genetics is very much about. Right? Darwin had no real clue. Of course, there was this guy, Mendel, who was a contemporary, a monk in Moravia, which is now part of the Czech Republic, and he published very famous studies, which gave a kind of mathematical account of how reproduction happened, what are often called the laws of heredity. But Darwin could not read German, and Darwin was not all that great in mathematics either. And so he basically ignored this stuff. And so there wasn't a lot of attention paid to Mendel, but it did get rediscovered in the beginning of the 20th century. And that's when genetics really comes into its own in the way that we understand today as a basically laboratory-based science, right, which initially was studying reproductive patterns of insects, right, fruit flies, mosquitoes, things like that. And then gradually, right, as our understanding of genetics became more profound, right, getting into the molecular basis of it, and so that we can understand the genetic makeup of large-scale organisms, including ourselves. And of course, we have the Human Genome Project at the end of the 20th century. And now we have all of this stuff about gene editing and bioengineering and all that jazz, right? And that is largely due to the genetics. And in a sense, this kind of knowledge, in a way, developed quite independently of where Darwin was coming from. But nevertheless, in the 1940s, you start to get this thing called the neo-Darwinian synthesis, right? The neo-Darwinian evolutionary synthesis, which you've probably heard of. Right. And so this is where Julian Huxley, who I mentioned here, is really an important figure, especially in the United Kingdom, because he is the first British person to actually put Darwin's theory together with genetics as it was understood in this middle third of the 20th century, and then opened the door then for the kinds of developments that we started to see at the end of the 20th century and carry on to this day, right? So genetics got married to Darwin's picture. And Julian Huxley was very much part of this scene. And he had a very particular take on it, which in a way, you might say, inclined him toward taking science fiction seriously. And this had to do with the fact that he believed, and this has a lot to do, I would say, with his background, okay? So in case you don't know about Julian Huxley, so Julian Huxley is born in the late 19th century. He dies in 1975. So he is living pretty much throughout, very significant period in the 20th century because, as you probably know, with regard to the history of biology, within 10 years of this neo-Darwinian evolutionary synthesis happening, we actually get the molecular revolution in biology, right? Which we associate with the discovery of the double helix model of DNA, right? Watson and Crick and all that jazz, right? And that really becomes sort of the foundation of the kind of understanding of genetics that we have now. And it is basically the framework within which people think about gene editing and bioengineering and all that kind of stuff, right? And so Huxley's there for the whole thing, right? And after World War II, right? So after World War II, he is the first scientific director of UNESCO. Okay. And what that enables him to do, okay, so let's get UNESCO here. What that enables him to do is to, in fact, stop efforts to put a ban on genetics research because of all of the atrocities that the Nazis had committed. Because look, you think about it, right? World War II, you could have stopped all of nuclear energy research. And in fact, there was a very serious ban in the use of nuclear energy until the recent time. And that was because, of course, the atomic bombs that were dropped in Hiroshima and Nagasaki in Japan by the United States to end the war in the Pacific. Okay. So, but Huxley was, in fact, even more successful, you might say, in terms of completely allowing genetics research to carry on despite all of the eugenics research done by the Nazis, blah, 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 and especially the way in which these eugenics projects were deployed in the concentration camps, right? And so Huxley was very much a kind of a shepherd in terms of enabling science to progress, despite the fact that science had all of these potentially seemingly bad consequences, at least with regard to warfare. And this wasn't the first time that had happened. That had also happened in World War I as well. I won't talk about that at the moment, but if people are interested in that. But the point is, as soon as we started moving into World War terrain, right, where war was being fought at multiple fronts simultaneously, and it wasn't just, one country fighting the country next to it, right, but it was kind of global thing. Science was very definitely implicated in that because science is what enabled that kind of globalization of warfare to happen, okay? Huxley was a very cool character with regard to this because even though, he wasn't supporting any kind of serious war effort, nevertheless, he believed that science needed to make it through this, okay? And so part of the role that science fiction plays in his thinking, and he's not alone in this, okay? So one of the things that you may not know, again, about Julian Huxley is that in the 1920s, so around the time that this essay on the tissue culture king was published, he did a multiple volume popular work with very, very famous, one of the founders, you might say, of science fiction, H.G. Wells. And it was called The Science of Life. And it was originally serialized in a magazine, and then it was published as separate books. And part of what this science of life thing was about, it wasn't just simply or even primarily a kind of compendium of all the biological knowledge known in the 1920s. No, it was very projective, right? Very much in the spirit of science fiction, in that it spent a lot of time talking about where we could go from here. And so eugenics was very much part of the story. They were also very much keen on the emerging psychological science of behaviorism, right? And in particular, Ivan Pavlov's work, right, where he was able to train these dogs to salivate to a bell, and then so what's called in the trade instrumental conditioning, and so all of that is actually given quite a lot of a prominent feature, and it was also clear, if you read the book and you think about it from if you read these books and you think about it from a sort of ideological standpoint, um, that was kind of what we might call leftist progressive. It looked at the recently established Soviet Union, which is where Pavlov worked, of course, as a very progressive, ahead of its time kind of place, right? And that because you actually had a state, right? Remember, think about Marxism. Marxism, uh, you might say, advertises itself as a kind of scientific way of understanding people and society and so forth. And Soviet Union, of course, is devoted to this Marxist ideology, and part of the publicity, you might say, and this carries on throughout the 20th century with the Soviet Union, right? It's a very pro-science. Science is going to vindicate, right, the superiority of this kind of socialist way of doing things above the capitalist way of doing things, right? So science is there to promote this particular progressive ideology. And while Huxley himself was certainly no card-carrying Marxist, and certainly H.G. Wells wasn't either, nevertheless, they were among the Westerners who really, in a way, tried to bring the Soviet Union, you might say, out of the cold and sort of normalize what they were doing as something that, even liberal capitalist societies ought to be thinking about. But they didn't do this in any kind of mindless or sort of devoted way, but in a critical way, but in an accepting way. And you could judge it for yourself looking at these works, but you find there very much, especially if you think about where we are now with biology, a lot of what they were talking about, 100 years ago now, right? Kind of came through, but a lot of it seems much too ambitious, especially with regard to the ability of this kind of scientific knowledge to reformat how society works. And this is the thing, of course, that science fiction is always promising, right? Right. That there's a sense in which, and it's what makes it compelling in a way, right? Because there's always some kind of scientific premise to it, right? And then it's sort of extended, and then it's sort of applied, right, to usually the future, right? Or it may be applied to other planets, other places, and so forth. And here I would make a comment about Huxley's short story, the Tissue Culture King, because right, the story takes place in Africa, in the deepest, darkest Africa, right? The parts of Africa nobody has found out about yet, right? It just gets discovered. And this is actually a very common kind of pretext for a lot of this kind of science fiction work, that in some sense, especially when it's futuristic, right? I mean, now, of course, because we could send rockets into space and we have a history of doing that kind of thing, right? It's quite common, right, for the future to be located somewhere in the outer space, right? In some other planet, some other galaxy, right, somewhere else. But if you're looking at the early mid 20th century, before we start to get the space race between the United States and the Soviet Union, it was quite common actually for science fiction works to be located right where the future is somewhere remote on Earth. Right. So the island of Dr. Moreau, for example, right? Frankenstein takes place in a kind of remote, whatever, Swiss mountainous kind of thing. Right. Right. And the same thing with the tissue culture king, right? Where there's a sense in which the future is treated as a kind of unexplored space and a space on our Earth. Um, and by the way, this kind of idea, the mentality that informs this kind of way of thinking, is actually present in contemporary scientific works. And some of you may know of the contemporary scientific author William Gibson, who wrote this very influential book, Neuromancer, and he says. The future is already here, only unevenly distributed, right? Right. And you could take that to mean various things. So, for example, it might actually be a commentary about the inequalities in wealth and advancement, or understood at a fairly ordinary political economy level, right? You could understand what he's saying that way. But you can also understand it as a way of talking about how science fiction is able to access, these kind of alternative worlds that in a way put a mirror to ourselves, either positively or negatively. Right. So the future is somewhere else on Earth, and in a sense, we can actually access it, right? We can access it to be there, right? So it's not understood as a pure fantasy, right? And this is I think a very important point because science fiction is closely connected in terms of a literary form, is closely connected to a fantasy. Okay. And when we think about fantasy, of course, we start thinking about, fairies and goblins and, all of that kind of stuff, fairy tales, maybe, right? All this kind of stuff. Now, one of the things that all these forms of fantasy have, um, and I put this for you to think about, right? Which is that fantasy tends to be very much based on nostalgia, right? So in other words, it tends to be a kind of exaggerated understanding of how one imagines the past to have been. Okay. I think this is pretty true if we're talking about Peter Pan, and I'm just thinking about all these various fantasy things that remain popular today. They always take us back to another kind of time and place, right? Where things were simpler, and it gets exaggerated, and often it's sometimes put in an ironic context because it can't really survive in the world we live in now, right? And so you think about the Wizard of Oz and things like that. So there's a very strong past orientation where the past, a certain image of the past is seen as quite positive, and you can kind of go there for a little while, but you can't stay there forever, otherwise you'll die, right? So fantasy has this character, and that pre-exists science fiction. Now science fiction in a way takes a lot of the motifs from fantasy, but of course it is futuristic, right? And so the futuristic character of science fiction makes a big difference. And also, right, because the future doesn't yet exist in the way in which the past did, what we're talking about is not imagining something that happened before, right? In some sense where we have a kind of partial recollection or partial memory of it. But rather we're talking about our plans, right? We're talking about where we want to go. And then, in a sense, what science fiction does is it sort of takes that literally and confronts us with the consequences of it in various sorts of domains. Okay, uh, and um, and so this is one thing where you know the kind of why science fiction is very rarely completely utopian, right? Right. Utopia, you might say, is a kind of a relatively neutral term in this context, right? Utopia is literally from the Greek meaning nowhere, right? Nowhere. That's what it means, right? You means no, and the topia means place, so nowhere, no place, right? And of course, both fantasy and science fiction, right, in a sense, have this kind of utopian character in that you cannot find where it's located, right, physically. Um, but the point is, it exists in the mind and in the imagination. And so fantasy and nostalgia are, fantasy and science fiction are kind of two ways to go on this. And it would be interesting, actually, to do a kind of ideological study about the kinds of authors and audiences that tend to be receptive to fantasy on the one hand versus receptive to science fiction on the other. Okay. And so this is where Huxley's coming from. So Julian Huxley's work on this is very much in line with the likes of H.G. Wells, right? Who I mentioned earlier, right? H.G. Wells with The Time Machine, War of the Worlds, right? The Island of Dr. Moreau, right? All of this stuff. This is kind of where Julian Huxley is coming from on this matter. The other thing, of course, to say in this context, which is very important, is that Julian Huxley is the brother of Aldous Huxley. Okay? And Aldous Huxley, um, you might say, he's the author of perhaps the most dystopian, right, science fiction work of the 20th century, which you probably know, Brave New World. Okay? Um, Now, one of the things that's quite interesting about this work, about Brave New World, which in a way gives you in a way exemplifies something that a lot of science fiction actually tries to do with varying degrees of success, is that it tries to, in a sense, and this goes to the issue of the literalism. Right, because here's the deal, right? When we're talking about what the future can be like, right? Let's say I'm a futurist, or I'll say more in a few minutes about transhumanism, which I have some association with, right? And by the way, transhumanism was coined as a word in the 1950s by Julian Huxley. Okay, so transhumanism and Julian Huxley very closely connected together. And just to add one more little detail to keep you thinking about this, is that in the final decade or so of his life, right? I said Julian Huxley dies in 1975, right? He is probably the most venerable champion, right, in the sort of public science, science communication sort of community for in vitro fertilization, which is something that is already being anticipated in the 1920s, and is something that Aldous Huxley, right, ironizes, right, satirizes even, in Brave New World, right? In vitro fertilization, right? The idea that you can have test tube babies, right? And that, in a sense, right, that the reproductive process can happen outside of the biological mother. Okay, and so this is and this, by the way, this idea in the 1920s when it was being promoted, okay, was being promoted very seriously by feminists, because the whole idea, right? If you think about the way the biological process works normally with regard to reproduction, it basically puts the woman out of commission because she's got to bear this child in her body, right? And from the standpoint of all of these kind of progressive left-leaning kind of thinkers, you know, within the biological space, right? So in other words, biologists thinking about this who also happen to be liberals or socialists or whatever, right? That in a sense, this becomes, as it were, a biological basis for the asymmetry, the inequality between men and women. Right, because the women bear the child. The man just has to inseminate the woman, but the woman is bearing the child. And so wouldn't it be better from the standpoint of trying to equalize the sexes, that in fact you try to come up with a system that systematically enables reproduction to happen outside of the body through some kind of mechanical process, and then in that case, then you can have the male and the female, right, contribute their eggs and their sperm, right, and then they can be combined in this mechanical fashion, and the child can be born outside of the womb. And the argument was made at the time that, and this, by the way, this process, this general process of which in vitro fertilization is one example, right, is called ectogenesis, right? Which literally means born outside, right? And so this was seen as a very progressive kind of move, and that in a sense biological science ought to be geared toward this, because then it allows for lots of things, and one of them, which is part of what Brave New World actually, what shall we say, in a way satirizes. Again, Brave New World is a kind of a satire of things that if you took that in a way starts from taking literally, right, various kinds of futuristic ideas about science that people like Julian Huxley and others, J.B.S. Haldane is really the man who brought all this to light, and he's one of the founders of population genetics. In a sense, this is kind of a world where if you have the child born outside of the woman's body, it can then be subject to what should we say? Collective legislation. In other words, you could start thinking about stuff like, well, who do we want? Whose eggs do we want? Whose sperm do we want? For what, how should they be combined, given what we know about the genetic traits of the various individuals, right? And then you could actually have a kind of political process by which you decide which sorts of people are born. Right? I mean, and so the whole ectogenesis thing was also very much wrapped up in a kind of a democratic, socialized kind of conception of how children ought to be brought into the world. Now, you see, if you've read Brave New World, you could see this a mile away, right? Because Brave New World takes this deadly seriously. Right? Deadly seriously. And there's a planning board about what sort of children need to be born. And because the knowledge of genetics of this society is incredibly advanced, right? You have alpha, beta, right? Gamma, delta, epsilon, right? So you have these classes, almost like a caste system, right? Based on the kinds of sperms and eggs that are being combined, essentially to sort of bake these kids into existence, right? And the imagery that Aldous Huxley suggests in terms of how ectogenesis works is not the test tube baby, but it's more like a bakery, right? And you could sort of understand, what he has in mind. So the point that when you read something like Brave New World, right, the point about that work is that most of the people who are living in it take it totally straight, right? They see this as progress, right? But of course, there are a couple of people coming from somewhat different places in the society who don't think so. And in a way, those people, those kind of weirdos, right, become sort of the mouthpieces, you might say, for the kinds of critiques that Aldous Huxley is trying to make of this brave new world, which in many respects is bringing about literally what people like his brother and JBS Haldane are arguing for as the future application of biology to society. Okay? So this is science fiction, and a lot of science fiction has this kind of character to it, right? Where in a sense, a lot of it is predicated on an extension of a fairly literal understanding of developments that are currently going on in science and technology. Okay, and so that's something that's worth keeping in mind, right? In terms of of the function of science fiction. Um, Now, I want to and let me maybe I should at this point move to talk about transhumanism a little bit, okay? Because transhumanism is in a way, transhumanism is kind of what Aldous Huxley is satirizing in Brave New World, right? I mean, there's a sense in which, transhumanism. So transhumanism, just to make it clear, right? Because I want to draw a distinction here between transhumanism and posthumanism, which you've probably also heard of. Sometimes these terms are used interchangeably, but they're really pushing in different directions, at least with regard to the relationship of humanity to the future. Okay? Now, transhumanism is basically about taking qualities that we already value in human beings, typically intellectual qualities, but other qualities as well. But and amplifying them, right, through some kind of scientific and technological enhancement, right? So, in other words, human beings are great but they're not great as they are. There is room for improvement with regard to really getting the most out. So, in other words, to create a human being who can match the human aspiration, right? So, human beings, we're constantly saying we can understand everything. We can understand the world. We can fly off to other planets. Think about Elon Musk, right? Elon Musk is a classic transhumanist in this sense, right? This guy, the sky's the limit. He claims we can do anything. Well, transhumanism basically says, yes, but we're going to need to reformat ourselves. Now, what that means among transhumanists can vary, right? And it's interesting. Elon Musk, I would say, is a very much a kind of biologically based transhumanist, in the sense that he's very much focusing on human reproduction and improved human performance, and so he's taking Homo sapiens, right, the biological being Homo sapiens, as the platform from which then we build the human. So in other words, another way to think about this is that the transhuman for Elon Musk looks pretty much like a human, only more powerful, right? And being able to do more and things like that. Right. So in a sense, Elon Musk doesn't question the biological fundamentals of humans all that much, but wants to amplify them. Right. And that is certainly one way of looking at transhumanism. And some of those people, want to go further, and I think further than even Elon Musk wants to go. And they are very much preoccupied with longevity, right? So in other words, it's not just that we need, more powerful, more intelligent humans who can do more things because our technology enables us to do so, blah, blah, blah. Right. But there's a sense in which we also need to live forever. Okay. And the guy who, Aubrey de Grey, British, originally a computer scientist, but now a kind of great advocate for longevity research. And longevity research typically involves sort of reverse engineering the genes, in the genome in particular, to repair telomeres. And these telomeres are the things that, as you probably know, right, we are constantly reproducing ourselves. Right. So we don't have the same cells as we had when we were born, blah, blah, blah. Right. We have mechanisms in our body that reproduce them constantly. So you're constantly getting a kind of updated version of yourself from a physiological standpoint. The problem is, of course, as you get older, the quality of the copy declines. That's the telomeres start to fray. From looking at it from the genetic standpoint, right? So in other words, it's like you're getting faded copies of your original self. And of course, you last long enough, and this can lead to all kinds of dysfunctions, right, in the way the body works, which ultimately leads to death, right? You're right. So in other words, the failure of the cells to update themselves in a way that maintain a level of vitality is pretty much what causes death. Now, so these longevity people saying we could stop this, right? We can maybe even reverse it, right? Reverse aging, right? And perhaps, enable people to live indefinitely somehow. Now, that's actually a very popular proposition among many of the people who identify as transhumanists. And of course, science fiction stories have explored this, of course, and I do think it appeals to a certain segment of the population. Let's say people my age. So I am 65. I'll be 66 in a couple of months. And people who consider themselves very vigorous, blah, 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 right, want to stick around forever. And so they are looking for a kind of fix, right, that enables them to carry on. Now this, of course, if this were to happen, and it might happen, certainly there's enough private money being thrown at this. Okay, that's another thing too. This stuff may not be a very high priority item with regard to public funding of science and technology, but it's a pretty high priority in the private sector where you have a lot of rich older people. Okay, and so that's the constituency we're talking about there. And the other way you can go with transhumanism is in some sense to say yes. What makes humans distinctive, our consciousness, our intelligence, whatever you want to call it. What we need to do is to, in a sense, isolate that, right? Identify that clearly, and then transform it to a more durable platform. Okay. And this is where artificial intelligence and cyborgs and all that other stuff comes in, right? Where in some sense, we have to make a migration of whatever information or cognitive processes make us distinctive, that we need to have that migrate from Homo sapiens, either completely or partially, there are different scenarios about this, into a silicon form that's more durable, and not only more durable, but also more capable of sort of scaling up, right? Computational power, stuff like that, right? Our brains are fine, but they're limited in what it can do. But imagine if our brains or the contents of our brains or the way our brains work, right? Because we're trying to always provide computer models of the brain. Imagine if that were transformed to a machine that, in fact, can amplify this indefinitely, right? And there was a film about this about 10 years ago with starring Johnny Depp called Transcendence. And the punchline of that movie is that it ends up short-circuiting the Earth. Okay, but that's another matter. Um, and that's a science fiction thing, right? That's a science fiction thing because in a sense what it does is it takes this kind of idea, which is very alive, very popular, especially in the artificial intelligence kind of community, um, and it kind of literally looks at the consequences of it, right? It gives you say, okay, let's say we do this, right? Let's say this happens. Then what does this look like exactly? Okay. And so science fiction is very useful in that regard, in providing that kind of thing. Um, Now, before I close, I want to talk about one other aspect of science fiction, and I'm probably not going to spend as much time on it as I would like. And in fact, I thought I was going to talk about it more earlier. Um, but I think it is quite important to flag because maybe in some future iteration of this module, it might be made more relevant. And this is kind of the role that time travel plays in science fiction. And because I mean, you may recall one of the things that I said earlier about this course is that it is very much, pretty much ends at the beginning of the 20th century, and even a book like Brave New World was published in 1932. But all of the stuff that was going on in all that science fiction was very much before the revolutions in relativity and quantum theory really started to take a popular foothold, right? It was before that happened. And of course, the time travel motif in science fiction is, of course, one that you can find in H.G. Wells's The Time Machine, right? It's not it's not like time travel originated with the incorporation of relativity and quantum theory into the popular realm. But in a sense, these theories from the early 20th century, these physics theories from the early 20th centuries, really kind of changed the kind of look of what time travel might do or how it might function in a science fiction plot, right? And Because if you think about something like H.G. Wells' Time Machine, um, right? So you got this guy. He invents a time machine, goes back in time, goes forward in time. He sees all kinds of things going on, right? But pretty much the conception of time is it's like traveling through space, right? It's like going to other planets, basically, right? Except that in the case of time, they are in some sense ordered, right? There's a kind of sequential ordering of the different worlds that he encounters as he goes backwards and forwards in time. Right. And this then has some kind of lesson to teach us, to teach the reader, to teach the people in London in the late 19th century where the story is located. Um, but of course, when we start to get to relativity and quantum theory, um, we get a different kind of we get a new kind of look of time. I would, to put it in the most general terms, right, the idea that we can change the past and change the future. Right? So in other words, there uh, there is this much more interventionist kind of idea of the relationship between the time traveler and the various times that the time traveler moves around in, right? And this is quite interesting, quite profound. It's been exploited in many different kinds of ways, not only in literature, but of course in the movies, television. Some of you. So when I was a kid in the 1960s, you can look this up. There was this television program called Time Tunnel. And then, of course, in the UK at the same time, right? So Time Tunnel was in the United States. There was this television series that's lasted forever called Doctor Who, which some of you may know about, which is also predicated on this idea of, traveling around in time and doing stuff that then has implications that sometimes you have to undo and, whatever. And this has been like one of the most popular television series around the world forever, right? So obviously there's something very interesting about that. Another TV program from the late 1980s, which got revived in early 2000s, which again I would recommend you look at because it gives you a different kind of spin on this, is called Quantum Leap. Okay, and Quantum Leap, what makes it distinctive is that the main character, when he travels through time, the way he lands, so he doesn't land as an independent individual, right? Where he might, cause things to change in various ways. Rather, he lands in the body of someone of that time, right? So his soul sort of inhabits their body, and then he has to figure out who he is and what he's doing, right? That's an interesting way of spin. And then finally, I would one other series which lasted for about 3 or 4 years in the early 2000s, and a really interesting, very very much gets into this in a very deep way, but ended up getting canceled because there was this big writer's strike in Hollywood in 2007. Okay, but it's called the 4400. 4400. Now, this is CBS in the United States, and what was going on there was that people from the future, right? So you start off with the future. People from the future realizing that their world is going to end, and there's nothing they can do in the present to stop that from happening. However, these people also had developed time travel technology. So they got time travel technology. So in a sense, what they can do is to be able to go back to the past and change the past so that the future enables them to survive. Okay? And so the way they do it is by going back to the past and they figure out some moment in the past where things could have been changed in a way that would not lead to the disaster that the people in the future are living with, right? So you in a sense have to kind of figure out what is the fork in the temporal road, right? At what point, right, could we have changed things so that it wouldn't end up this way? This is a very important part of this kind of new look of time travel that you start to get with relativity and quantum theory. Namely, you think about where do you intervene exactly? So what they do is they end up taking people from the time in which the program is located. So in the early 21st century, right? They take 4,400 of those people, they take them back to the time of the future, they kind of reformat them in various ways, and then send them back so that they can, change the course of history, basically, to make things better. But of course, this is easier said than done because there's all kinds of ways in which stuff that happens, right, once you're put back there, can end up changing things, and causing you more problems and, problems that in effect have downstream consequences for the future. And so this program was actually very good at capturing a lot of the emotional and kind of interactional aspects of this. If you're someone who originated at a given time, but then you've become this person informed by the future, and now you're back to where you were originally. How do you respond with the people who are supposedly your contemporaries? Right? It's actually excellent program for that kind of thing. And so what I want to say about that is that why is this so compelling? Why is this kind of this version of time travel, which involves changing the past and changing the future, so compelling? Well, it's because, of course, we are constantly, we have problems with our past normally, right? So, so for example, if in the Western world, as you know, there's concerns about reparations and compensation, right? So, in other words, or restitution, it's sometimes called, right, where things that happened in the past, which were considered very bad, in some sense, we have to kind of undo them in some way. And one of the problems that we have in the present by not being able to time travel is that we in a sense always feel unfulfilled, right? That in some sense the desire ultimately is to have changed what happened in the first place, rather than to have to make up for it after the fact. Okay, and so from that standpoint, this kind of time travel approach to science fiction, right, is seen, you might say, as an agency of justice, right? Setting the world right and all the problems that's involved in trying to be an agent of justice as a time traveler. Okay, so I am going to stop the lecture here because I think there's a lot for you to think about. And I'm happy to address any of this stuff after we have the break. So I'll end here and thank you for listening.